MRI. And who will do it? Laysa lil insana illa ma sa'a. Pakto ki hui palalasa or golalasa. So munginiku, it's a casa, it's a munglaiti. What should be the structure? This was the structure I proposed in 2006, that we should develop basic units. I visited Gunair, and there are millions of tons of marble scrape. What is in marble? Marble is silica, calcite, mainly it is calcite or aragonite. Magnesium, aluminosilicate or calcium oxide, calcium carbonate. There is some quartz content in it. You mix gypsum with it and it will give you the cement. And it is an excellent market. There is no such industry in Swat or nearby, in Afghanistan and nearby, and it is a big market, large market for your cement industry. You have numerous resources of Nepheline cyanide. Nepheline cyanide is the fundamental ingredient for glass technology. So look into these and you move around, you can do many things. But this can be a place where you can bring together the government, the industry and the academia. Academia will design the project, academia will design the products, industrialists will tell the cost and how much cost is needed for it and what sort of product we need, and the government should support it officially. I failed, I couldn't bring them together. I talked about these things to the governors, I talked about these things to the HEC, and when the HEC people came, they told me your project was excellent, it was highly appreciated, but your university is not interested in it.
And it was in 2006.
In 2006-7, like that. And when I came to my university, I asked the Vice Chancellor that you are my university. Why are you not interested in it? He didn't reply. So this is the main game, that you rights. But what we can do, my students will tell you that we could start from clay and we reached it here to the nanofiber. I developed the lab in Peshawar and we developed our own equipment which could make nanofibers. So individually, we can do a lot of things and we should do it. A day will come that all these things will be needed. So from there, I could reach here in 19 years. We had developed our own kits which could make nanofibers. We can now simulate solar cells inside our lab. We developed the downshifting glass which I told you in the start, that you can downshift the photons coming from the sun to the usable photons. So you can do many things with the available resources instead of wasting our time on memorizing and different things. The key, this can turn your rocks into more than gold. All these are the benefits. And I will tell you in the end, one thing. I used to think, and you may be thinking, that the whole world is working hard. Is there any more room left for research? In 1900, when the Newton and Kepler and all these laws were developed in a very systematic manner, physicists were thinking that there is nothing more left in physics. At about 1900, they were thinking that the whole research has been done and there is nothing new which we should work for. But what happened from 1900 to 2000? You found Einstein, you found Stephen Hawking, you found the Rutherford and all these people who explored the new world, the new universe, the expanding universe, and everything changed. And you, at the end of the year 2000, you were a human being of quantum technology. So much development was done from 1900 to 2000 that during the whole human history, you put that in one pan and the other in the other pan, and you will see that 20th century development are like this. So much development was done. How it was done? Just a simple example. Carbon is about 24,000 years old element. And the mankind knew it from the thunderstorms which burned trees, and they were burn wood in the form of coal. People knew it 24,000 years ago. When people learned about writing, so they used the same copper for writing. And today you look into your pencils, they are made of graphite. It is 100% carbon. Graphite is 100% carbon and it is very soft and that softness is used for writing. It erodes when you put it on paper. Soft thing. How softness is today, the weaker bonding the graphite structure. The graphite crystal structure is disconnectivity. Parallel planes the softness. When men discovered steel, it couldn't be cut with iron or steel. And they used diamond saw. What is diamond? 100% carbon. Because of its hardness, extreme hardness. And when that was done, people thought carbon is finished. All the discoveries related to carbon have been done, and there is no need of any further research in it. But in 2010, the Nobel Prize was given by the Nobel Committee to two scientists from Manchester University on graphene, and graphene is also 100% carbon. And a graphene institute was established there in Manchester. And you go to a laboratory in Saudi University, any university in Islamabad, Karachi, Japan, America, anywhere in the world, and you will see people are working on carbon nanofibers, carbon nanovisker, carbon dots, and you name it, and they are there. And there are individual journals using the name carbon. Carbon is a journal as well. And all over the world people are working on it. So, this means that the humanity, we the human beings, have not yet discovered the single element carbon. So think about the whole universe. It is all undiscovered. You are still have to live for 300 billion years. The mankind, you are here, and you will find new materials, new products, new properties, and the world will always be changing like this as it changed in the 20th century. So the research never ends. It ends. Which is that one day you are a living being. When you think at the end, the world, the universe is so big, it is so huge, it has so many opportunities. Exponential increase about that because of science, because the humanity developed new products which increase the products. So Allah the Almighty has given you everything in this universe, and this is my and your duty to explore it and utilize it for the better life of the living beings, not only human beings, okay? The living beings, and you will be successful. Thank you very much.
Thank you.